All right, I'm going to go ahead and go over the odd answers to worksheet 9.2. These are areas of a circle and sector area. I've already done some notes. I actually, in notes for 12.4, I covered sector area along with arc length, and then went over 9.1 completely, which was arc length, and now 9.2 is focusing on sector area. All right, so find the area of each shaded sector of a circle. Leave your answers in terms of pi. So remember, we talked about this a couple times. To find the sector area, that's the shaded region, we find the area of the entire circle and then figure out what fraction of the circle is the shaded region. Like this one's pretty easy. You can see it's a 90-degree angle. So we have a 90-degree central angle or a 90-degree arc, which means we are really looking at 1/4 of the circle. So if we find the area of the entire circle and divide by 4, we would have the area of the shaded region or the sector area. So let's just review. Sector area equals the area of the circle, pi r squared, times the arc measure, or you could say central angle, over 360. I like to say the arc. I think it's a little easier because we know it's the arc of the sector. So in this case, sector area equals pi times 4 squared times 90 over 360, which means our sector area is 16 pi, that's the area of the entire circle, times, when I reduce, 1/4 of the circle. So our sector area equals 16 times 1/4, or 4 pi. And remember, we don't have a unit here, so we'll just put units squared because it's area. All right, going on to number 3 over here. The sector area equals the area of the entire circle, pi times 3 squared times 45 over 360, which means sector area equals 9 pi. 3 squared is 9. All right, well, hopefully you know that 45 is 1/8 of a circle. If 90 is 1/4, 45 is 1/2 of 90, so 1/8. So we end up with a sector area of 9 pi over 8, and that answer is great. We want to leave it in terms of pi. Some of you might want to divide 9 by 8 and come up with some decimal, but I really prefer the fraction. Okay, moving on to number 5. So sector area equals pi times, well, we have a diameter of 10, which means the radius is 5, times 180 minus 72 is 108 over 360, which means sector area equals 25 pi. Now, if we got one that isn't quite come to your mind real quick, we can simply go 108 over 360, and you get 3/10. And if you want to continue down that road, we can simply go times 25 pi, and we get 15 pi over 2. Okay, number 7, let's do it all on the calculator. So first you always got to fill in your information. I need to see that. So that would be pi times 3 squared, the diameter is 6, so the radius is 3, times, well, we're looking for everything but this 45, so that would be 360 minus 45, or 315 over 360. That's the fraction of the circle. Okay, and let's plug this into our calculator here. So let's see what we got here. So I'm going to put it even in parentheses. Parenthesis, pi times 3 squared, end of parentheses, new parentheses, 315, you know I love that fraction button right there, over 360, get out from underneath, and end. So you can see these two look identical, and you hit enter and you get 63 pi over 8. Alright, number 9. Alright, this one's going to be pretty easy. But again, it's good practice. Sector area equals the area of the entire circle, which is pi times 1 squared, radius, the diameter is 2, so the radius is 1, times 180 over 360, which means the sector area equals 1 squared is 1, so 1 pi is simply pi. 180 over 360 is 1/2. So our sector area is simply pi over 2. Some of you might prefer to write it like this as 1/2 pi. That would be fine. Either way. Okay. Now we want to go on, and we're basically giving you no picture, but we don't actually need it because we have all the information we need. Find the area of the sector RST in circle S using the given information. Leave your answers in terms of pi. Alright, so again, sector area equals pi times radius squared times arc length over 360. So we get sector area equals 64 pi times 1/4. And let's see, sector area equals, what's 1/4 of 64? That's right, 16, very good, 16 pi. Okay, now this one's going to be a little trickier because our sector area equals pi times radius. Well, we have a diameter of 13, so our radius is 6.5 squared times 120 over 360. I was just noticing they switched up RT and TR, but those are the same arcs. Doesn't really matter. And so we get SA equals, well, what's 6.5 squared? 42.25. So we get 42.25 pi times basically 1/3, right? So let's go ahead and multiply that out because we shouldn't have fractions and decimals together. So let's take 42.25 pi and multiply it times 1/3. And again, these calculators make it so easy for you to mix decimals and fractions. And we get 44.42 because there's decimals and fractions, they went ahead and multiplied it out. But let's just try this. Let's clear it and go 42.25 times 1/3. And now we'll just get our number, enter 14.08. Let's call it 14.1. That way we leave it in terms of pi. Okay, moving on. This is a great one. Alright, I was hoping I'd do this one and leave that one for you. Because that's a little trickier. You'll probably see this if you ever take a test on this, which I don't think you're going to. But what I'm going to do is I'm basically going to take this square and I'm going to cut it in half like this. I'm going to cut it right down the middle. I'm going to take this guy and I'm going to put him over here. So now if that circle goes like that, okay, the circle is going to go like this, and that shaded region is over here. And this no longer exists. So what I'm trying to point out is these two questions are identical. Alright, we just basically cut this in half and move this part over here. Same questions. So what are we going to do to find this shaded region, which is just these little kind of corners here, these circular corners? Well, it's pretty easy. On these questions I like to draw a very simple diagram that helps. If we find the area of the big square, and then we subtract out the area of the circle, that will leave us all the shaded region. So we find the area of the square and then subtract the area of the circle. Well, I kind of messed up our drawing here, but you can see we have a square that is 4 by 4. Okay, so basically it's 4 squared. To find the area of a square, you multiply the length times the width, or the base times the height. 4 times 4, or 4 squared, is 16. So that was pretty easy. Now we have to find the area of the circle with a diameter of 4, which means a radius of 2. So 16 minus pi r squared, or 16, that's the area of the square, minus the area of the circle. You'll notice they said leave it in terms of pi. So that's really all we can do there. We could reduce it a little bit. If you think of this as a binomial, we could factor out a 4. We pull out a 4. 4 times 4 is 16 minus pi, because 4 times pi is 4 pi. So that's one way we could rewrite it if we wanted. Either way is fine. And there's our area, either here or here. All right, number 17, last one for me. An apartment complex is replacing its grass seed in a play area. The area of a circle that is 30 feet in diameter. They need 1 pound of grass for every 300 square feet of sod. Find the area of the nearest 10th square foot. Okay, well, I just did one like this on another worksheet. Let's see if it's the same. I don't remember if it was 30 feet. So I think it was. So we have a diameter of 30 in our circular play area. So to find the area, we go pi r squared, which means area equals pi times 15 squared, which means the area of our circular grass area is 225 pi. Okay, and that is feet. Okay? All right. So how many feet is that? We need to multiply it out. So we have 15 times 15, I already did that, times pi, and we get 225 pi, but we want an actual number, 706.85. We're going to round to the nearest tenth, so 706.9. So our area is 706.9 feet squared. Okay, but a bag, 1 pound bag, will cover 300 square feet. So we actually need 3 1 pound bags. So we need 3 bags of seed. 2 bags would cover 600 feet, but we have a little over 706 feet, or almost 707 feet. So we can put it on extra thick or have a little extra left over. All right, guys, hope that was helpful. That is 9.2.